Okay, let's get started. Where were we? Now this. We were up to the point. We said programming. All right. Isn't that a relief? Okay, so these questions are numbered. That's because you can put the number in your text document. Like you can say answer 1 and then write the answer to that. Right? Don't type that, but type your own answer in your own words. I'm not after how correct it is. Okay, I don't care whether your answer is correct. What do I not care about? Louder. What? I want everyone to say that. I don't care if. That's right. Louder, please. I don't think everyone got the message. See, this is the same thing that I said earlier. People have internalized notions already that if you're submitting something, if you're clicking OK and uploading, then it has to be perfect. That's not the case here. All right? So, repeat after me. It's okay if my
answers
are not
right.
Right, that's fine. Okay, so it's all good. Okay, so we are on the same page about that. So write whatever you think in your own words. Don't worry about perfect spellings, perfect grammar, perfect English. It has to be in English, by the way, because it's a requirement. Anyway, so why do we program? All right, people will say, okay, because it's science, man, or it's important. And people will say it's because it's powerful and you have to learn programming. It's the future. But really, open up a new tab in your browser, go to COSC, right? Who's familiar with the website COSC? All right, a few people have sought COSC. All right, seriously, who has heard of COSC before? All right, good. All right, you go to this one. 150k jobs, right? And have a look at, where is it? Science and technology, yes.
Now we should go to information communication technology.
As well, yeah. So, but let's just have a quick look. What do we have up top? This is a paid one, featured, but senior data analyst. Do you think a data analyst might need to know some programming? Probably. Plant biology, maybe not. Data scientist. Yeah, maybe not. Yes, probably. Programming. Yeah. If they are going to pay you over. Sorry. Yep. Machine learning. Yep. Data scientist, data analyst, predictive modeling. Oh, did I click on that? Okay. What else? Data scientist, weapons, propulsion, propellant scientists. I'm sure they will benefit from programming. Managers, probably not. I don't know. Group leader, chemical and biological individual protection, hazard management, maybe not, because it's a sort of like a leader role. So senior or lead data scientist. Do you think a data scientist or a lead data scientist can talk to other data scientists without knowing much about programming? What do you think? Honestly, what do you think? I don't think anyone can fake it that well. All right. So you need to know programming, because for leaving all other reasons aside, if you're going to do some top-paying jobs in this field, it's going to need programming. All right. So programming is important for that. All right. Leaving the whole thing about it's science, it's important, it's powerful, all that aside. If you are planning on getting a job related to this stuff, yeah, it's really important. Okay. So that's not me saying it. That's what they have listed. That's just live from the website. I didn't put those things up there. All right, so that's reality as it stands. So that's something all people should do. Go to COSC or some other job advertising website. Have a look at your dream job there. Aim high, aim for the maximum, don't aim low, aim for the thing you want, and see what you need to do that. All right, so question 2. So take notes as I'm saying this, all right? You have to take notes. I'm not going to pause too much. Could we have done without it? Okay, so now this is something for you to do. Search for famous programmers in history and write down a name or two. Now there are lots of articles. They will mention different people. I want you to search for this one. Famous programmers in history. Search in Google or whatever your preferred search engine is. Do that now on your machines. Type. Famous programmers in history. And write down a name or two and find out what they have done. Okay, let's get some names. Famous programmers in history. What names have you come across already?
Yes.
Bill Gates, all right, Bill Gates, fair enough. Bill Gates, we can't avoid whether you love him or hate him. Actually, nowadays, not many people hate him. There have been other people to hate. Anyway, so what did Bill Gates do? So write down, Bill Gates, famous programmer. What did he do? Of course, everyone here has heard of Mr. Gates, right? Yes?
Yeah.
Who has heard of Bill Gates? Of course you have. Can't avoid the guy. So, what has Gates done? Or what is he popular for? Microsoft, yes. And what did Microsoft do that's so significant? Made Windows. Now, you may hate Windows. You may be a Mac person, but let's face it. Windows is a reason why the whole world's using computers. Primarily because there was a time when everyone pirated Windows, right? Every corner of the world, there was a copy of a pirated version of Windows running. It actually worked to their benefit, in my opinion, because everyone became so familiar with Windows. Because, well, you could always get a copy for $1 or less. And nowadays, I don't think you can do that. Maybe you can, but these days we buy a laptop or something, it's already got Windows. But there was a time when we all had desktops and you had to install your own operating system, and a lot of people would just get Windows. They would get a pirated copy. And I'm not advocating it, but I'm just saying that that's the whole reason why the whole world's familiar with Windows to a good extent. Who else?
Alan Turing.
Alan Turing. Wow, he's not even in the list. Yep. What did he do?
Pretty much invented the program C.
Yeah. He's I don't know if anyone actually calls him a programmer, but he's one of the most important people. Full stop. Because it's because of this guy that we have the computers that we have today. They work this way because of the architecture that Turing came up with. I've heard many people argue that Turing was more influential to humanity than Einstein, because again, Einstein came up with some awesome stuff, which we'll probably use later on in the future. But right now, it's Turing's stuff that that matter a lot to us. His early work. So anyway, he was the pioneer of quite a lot of things, including hacking, right, or cracking rather. Going back, so who else? Who else? Brown who? Brian. Not BitTorrent. Okay, so there you go. BitTorrent. Why is BitTorrent an achievement? Who has used BitTorrent? People using. Doesn't have to be for evil.
Is that illegal here?
Huh?
Is that illegal here?
Is it completely illegal? I don't think so. It's
Not
no.
illegal, but some.
It's only if you pirate and do all kinds of bad stuff, right? Yeah. So anyway, you know BitTorrents, right? So it's important, right? Because it impacted people a lot, right? You probably watched a movie at some point that had something to do with BitTorrents. Anyway, what else? Who else? Some other people. I like to hear people voices from the back. Yeah, Grace Hopper. What did he do? Sorry, Grace. Well, I'm thinking of this guy with the beard. Anyway, sorry. Yeah. Yep. So Grace Hopper. Search for their name. Lots of names. Not Grave. Grace Hopper. And computer scientist and United States Navy. Yep. So have reads. I'm not a history expert. All right. So don't look at me for important people to tell you about important people. But this stuff you can find out. Now, wouldn't it be nice if your name was in that list at someday, right? Where do you think these people started? Do you think they were just they just magically poof and then they became popular? No, they started like you, right? So they've had ups, they've had downs, just like you. No one has ever had a clean run ever without ups and downs, and they got to a certain place. Find out what they did. Try to find out what common things they did. I totally, firmly believe that people here can be just as important as these people. Not right now, maybe, but later on, someday. But it's not in my hands. There's no magical teacher that's going to give you an injection of awesomeness. It's something that you have to develop. All right? If you want to be popular and be in a list like this. All right, let's move on. Hope you have written a few names. All right, next one. Now, we are all kind of familiar with what programming is. It's so difficult to avoid. There was a time when we had to teach people programming means this. But you've encountered programming at some point or another, even in a movie or something at least, right? So what is a language in general, programming aside? What is a language to you? I'm not asking for definitions. Form of communication? Yep. Anything else? Sorry? What is a language? What does a language contain? A language will have words, right? And it'll have rules about how you can organize those words most of the time. And basically the grammar rules. And then we use languages to communicate. Now you might tell your parents, I'm hungry, right? That's probably the first thing that you ever communicate, right? That you're hungry or you need help or something like that, right? So you ask them or you communicate and then they will communicate back. So it's the same story when it comes to programming languages. We want to communicate, except the computer is not going to warm your milk and give it to you, right? You tell other things to the computer. You don't say, I'm hungry. You tell the computer what you want it to do. You want it to process some numbers. You want it to keep some information together. You want it to extract some underlying patterns. You tell that kind of stuff to a computer, right? You don't ask the computer, hey, keep me warm, right? Well, although it might, depending on how inefficient the thing is. But anyway, so that's what programming is. Programming is telling or communicating to the computer, and it just so happens that our computers are at a stage where we tell them everything that they need to do. Right? So that's what programming happens to be, or computer programming. Right? And what is Java? What's Java?
One.
Mm-hmm. Well, one of many programming languages. And why is this not opening? It's terrible.
Universal language because it runs on many devices.
Yeah. Right. So human languages will have lots of words. Computer languages actually happen to be so super streamlined, right? Now, the English language has, I don't know, I haven't counted how many words are there, but it's just a ton. But if you take the Java language, there's 53 words. All right. Now, Java is an extremely popular language. You would have come across it at some point. Even when you try to maybe run some software or something, it might say you need Java, you need to update Java. If you buy a Mac, it comes with Java. So Apple thinks it's important. If that's any justification. Even something so powerful or widespread uses only 53 words. The language has 53 words. And you will come across most of these things during this semester. Abstract, assert, boolean, break, byte, case, catch, char, class, const, continue. You have already come across some of these things. We have seen class, right? We saw class. We have seen, what else? To do is just, that was a comment. We have seen public. So public class, there will be static somewhere here. Yeah, void we have seen. Where's static? I think I missed it. So we have already seen quite a number of these words. And just in the Hello World program that we wrote in the labs. So we are in a good position. All right, moving on. So that's so Java is one of many languages, many programming languages. And why do we need so many different languages? Did you ever think about that? Anyone?
To achieve different purposes.
Yeah, to achieve different purposes. Why are some people using Macs when you can do the same with a Windows machine? Or why are people using Windows machines when you can do the same with a Mac? Or why are people using Linux? Or why are people using Windows when they can use Linux? People also have preferences. They might all do the same thing at the end of the day. They all run on the same hardware most of the time, or similar hardware. Computers all work down low the same way with ones and zeros. But how can you explain why people use different things? Well, it's lots of things. You know, what they are familiar with, what appeals to them, what's suitable, what budget they have, how much time they have. If you have a lot of time in your hands, you probably will be using Linux, all right, because it's not straightforward most of the time. But if you want to get something done, you will go for a Microsoft laptop or an Apple laptop. No offense to those people who use this. But you know how it is, right? So it's the same with programming languages. So how are human languages different to programming languages? And why this is actually linking to my... All right. So try to search for this thing. And this is very funny, right? So this is English. We saw her duck, right? Now what does that mean?
We saw her duck.
We saw what? Duck what? right? Did we see her just duck for cover, or did we see her quack quack duck? Yeah, so those are human languages. They have what we call ambiguity. Yeah, they have ambiguity. They are not exact because uh, people didn't originate from a scientific or mathematical way of thinking. There has been quite a bit of logic in structure of human languages, but we haven't. We've done things the way we've just felt like, right? For example, Australian English is a little bit different to American English. The same way. Why is that? So uh, programming languages don't have ambiguity, all right, or they avoid ambiguity because you don't want to let the computer choose what to do based on how it feels or what it has spoken at home, all right. So uh, with programming languages we are exact, and even the instructions in this course, they are exact, sort of like programming instructions. They will try to be as explicit as possible about what you need to do. So that's why I said do them exactly as given. All right. So another one. One morning I shot an elephant in my pajamas. How he got in my pajamas, I don't know. All right. So you don't have that situation with programming languages. All right. You will be saying exactly whether it was an elephant wearing your pajamas or whether you were the one wearing pajamas when you shot the elephant. All right. So uh, we've all heard fruit flies like a banana. So anyway, the list is fairly endless. It's not just an English thing. It's also there in other languages. So yeah, have a look. Have a look. All right. So going back to our slides, so that's how human languages are different to programming languages. They tend to have ambiguities, okay? Whereas programming languages are exact. So what is a computer program? What is a computer program? Remember this slide? Slide number 4? This is, I said it's a recipe for success, right? So that looks like a program. We said you've seen programs here and there, and this is how a program is, right? As well. So a program is a set of instructions on how to do something. It can be like a recipe for cooking something. You first state the ingredients you need because you can't start cooking without having the stuff you need for it, right? You state the ingredients, then you explain the process step by step. You don't just say that you don't start from the last step. You start from what needs to be done next or what needs to be done now, followed by then after that you do what needs to be done next. Everything starts from the top and there are instructions telling you exactly the sequence, right? Sequence that you need to follow to cook whatever you want or to do whatever thing you want. So that's what a computer program is. It's a sequence of instructions that tells the computer how to perform an action. That's how I would explain it. All right. Any questions? Any questions? Nope. All right. Fairly straightforward. Hope you're taking notes. Digital ones and zeros and data types. Now, a lot of the traditional introductory programming books, they say, oh, the computers used to be analog with tapes and all. I'm not going to talk about that junk because it's not relevant to us, right? I mean, are we going to look at tape machines ever, right? Very unlikely, extremely unlikely. And so I'm not going to waste time with that. I know that you all are familiar with what a computer is. So you also know that there's a thing called digital, right? It's a word that we can't avoid these days. And along with digital, the thing that we hear sometimes is this thing about binary or ones and zeros. We also know from watching things like Futurama and all other tech stuff, techie shows, that computers and all digital electronics use ones and zeros for pretty much everything, for storing everything. Okay, so computers store data as ones and zeros. All right, that's understood. Now, how do they store numbers with other digits? Because if you have 2 or 3 or 9, how are you going to turn it into ones and zeros?
Like 1101, like.
Did you just convert in head?
Yeah, that's. I don't know the name.
That's good if you did. Yeah, you convert it. So you can open up your Windows calculator or something. Mine doesn't open up after I upgraded. But a number, let's say, I'm just going to come up with a number in decimal. So yeah, so this is cool conversion. All right, so here we go. So binary, that in decimal is 85. Okay, so there are all kinds of number converters. So we can convert from binary to decimal, and also I'm sure there are other bases, octal, hexadecimal. Contrary to popular belief, programmers don't come across octal and hexadecimal often. Extremely rare, extremely rare. But if you read about hackers or something like that, you'll always talk about hex and this and that, right? But it's mostly decimal that we deal with. We don't even deal with binary. We let the computer deal with binary. We speak in terms of decimal, right? So how do they store numbers with other digits? They convert those numbers to binary. Easy, all right? Numbers can be converted from basically any base. So decimal is base 10. You can convert from that to binary easily, and the other way around also, from binary to decimal. That's not an issue, all right? So that's that. So take notes as you go. Right. Question 8. How can computers store things that are not digits then? Okay, so if we can simply convert numbers, any number, to binary, what happens when it comes to A's and B's and all these other characters that look like, anyway. Yeah? Yeah, so it has to be a number. So you have to take the character or whatever the thing that is not a number and somehow have a consistent way of converting that or translating that or mapping that into a corresponding binary number. Now, who has heard of, you know what I'm about to say, ASCII? Who has heard of ASCII? Can I see hands?
Heard of?
Yeah, or used. Yep. So ASCII is everywhere, right? Now, again, so ASCII means one of those translations. It has a consistent way of converting certain characters to binary or corresponding binary numbers. Now, you might see me opening up Wikipedia every now and then. Now, I know some people are pretty reserved when it comes to using Wikipedia. I understand that. I wouldn't be asking you to write a report on some political figure and whether they were corrupt or not based on a Wikipedia article. All right, that's not a good idea. Those things are controversial. But ASCII tables, those sorts of simple things, there's not much controversy around those things, so they tend to be all right. So it's a good starting point. Anyway, whereas here's a table. All right, so these are the binary numbers, and these are things that are not numbers. So, for example, different characters will have corresponding binary numbers. We also have the more familiar numbers, characters. Excuse me. So, such as the space. So, the space is in decimal. It's ASCII 32. And if you convert that to binary, that's what you get. So if I type 32 here, Will it convert back? No. So it's the other way around. So anyway, try it out on your own. It's definitely correct. So space is 32, and all these other things that we had on the lecture slide, they also have corresponding binary numbers. So on any system that interprets what data that's stored in ASCII will use this mapping. So when it comes across this value, it means there has to be a space in that text. When it comes across this number or this sequence, it knows that, okay, that's an uppercase A, capital A. And if it's this number, which is decimal 97, then it knows that it has to be a lowercase a. So like that, there is a mapping for times when we can't convert from a character or something else, something that is not a number, to a number. So you might ask, okay, how come we have numbers here then? So these are not numbers exactly. These are characters. These are the things on your keyboard, right? So when you press the number 3 on your keyboard, it's recognized as an ASCII character with the decimal value 51. So we don't speak in binary. We don't go to that level. So everything has a corresponding conversion. So remember, when it can't simply convert from another number to binary, it needs to have some kind of mapping. All right. And what about instructions? We said programs are instructions, right? A sequence of instructions. So what's happening there? You can also give instructions as numbers. So if you search for machine code, that's like the lowest level thing you can get to when it comes to giving instructions. So here's how it translates. So this instruction is this number here, and then you tell which memory location to access by this large address number. Okay, so that's the binary number again. So so this is the decimal version, and this is how it is internally stored. So everything gets stored as ones and zeros, and it's up to you to specify how to interpret that. Okay, so if you are storing text, you need to say that it's text. Otherwise, the computer doesn't care and it can't tell. So if everything's stored as ones and zeros, how do we tell the computer what is a number and what is not? We will look into data types. Okay, so there are. So as I said, if it's text, you need to tell the computer it's not a number. It's what we call a string. Who has heard the word string in this context before? So most people have. Okay, search for that. All right, string programming, 2 words. Google it. Don't worry, this is not the last time you're going to hear it. We are not even introducing it here. I'm just giving an introduction to the overall thing. All right. So if you have a whole number, we call it an integer. No, that's just English. And that's what we call in the program also, we call it an int for short. And yeah, and then if you want a number with a decimal point, there are other stuff too. So like that, we'll look into data types eventually. Any questions? Yeah?
Are we using Unicode for now, and we just stop using that
ASCII. We don't go into, so Unicode is like a bigger version of ASCII, which has lots of other characters, not just the English and the normal keyboard stuff. It has characters from other languages as well. But because we are dealing with just English and a limited number of characters like exclamation, $, you know, the stuff that we have here. So we don't need to worry about Unicode in the first place. And the ASCII codes are actually compatible with Unicode. So it's not something we are going to worry about. Any other questions? Nope. All right. Let's move on. Okay, so revisiting Hello World. So we did this one in the class. So I am just going to go through this again. When you install Eclipse and open it for the first time, it'll ask you to choose your workspace directory. Where did I say you have to store it?
That's in
A folder on the desktop called ITP Workspace. So folks, it's with much sadness I have to tell you that some people don't do this. All right, they call it other things. They call it ITP space, ITP this, just space. They store it in other places, and not because they know what they're doing, it's because they just didn't read what they were supposed to do, and then they get lost. So remember how I said at the beginning, focus multiplied by time. All right, when you're putting in the time, just make sure that you're focused. You do the thing that you're supposed to do, not because I said so, because when we refer to some instruction, when we refer to some lesson, we all need to be on the same page about what we are referring to by that. We need to have the same understanding about what we talk about. So when I say look at your workspace, you should be looking at your desktop, and there should be a folder called ITP Workspace. All right. So I'm going to create that. I'm going to say launch, and I downloaded the latest version of Eclipse. It should look like that, and it's starting up, which is good. All right, any questions? All right, so another thing I said was in the instructions on in the lab, I said close the welcome page. So even little things. If you don't believe me, have a look. Where is that? Click OK and close the welcome page. So these are exact. All right, I'm not kidding. So you need to follow them closely as possible. Now I said every program goes into a project, right? So how do we create a new project? We go to File, New, and yeah, if you don't have Java project like this, all right, some people might just have project. That's okay. You can go to project also and expand general, expand Java and say Java project, because you want the Java project, right? Yeah, so choose Java project, not JPA project. There's a thing called JPA. You don't want that. All right. So the project name, what did we call this? My first Java program. All right. So there it is. And I say finish. That's all. What was that? Okay. There it is. All right. Cool. So if by chance there is a mistake, all right, what do? Now, I'll give you a little bit more insight to what's going on. If you look in the folder, the ITP workspace, which you should be having on your desktop, if you open it, you'll see a folder by the name My First Java Program, and inside it'll basically have the structure of your of the thing, the project that you created in there. There's no code in there right now. Now, what happens is, now this is the workspace. Don't go into the workspace and meddle around with it directly, okay? Unless I tell you to do so, because you can very easily mess things up. Now, let's say that you want to delete this project. How do you delete it? Do you delete from here, or do you delete from here? Do it the right way. Do it through Eclipse. Okay, so this is Eclipse's workspace. It's there for it to do its thing. You don't want to sabotage it. All right, so you right click on the project that you want to delete. Now there's an obvious one saying delete. Will this do the trick? Most of the time, if you say delete but you didn't check this one, all right, see what will happen. It's going to be here still, and next time when you try to create something by that same name, it's going to say it's going to go nuts, and you are like, I can't deal with this. All right. All right. Yeah. So anyway, if you did that, all right. If you don't have it here, but you have it in your workspace, delete that after deleting it from the main thing. All right. All right. Now it's okay. Okay. Now we can go and create a new one. Java project. So take notes as necessary. My first Java program. And we need to add a class. So now if you go into the source directory or the folder inside the project, you will see nothing there right now. That's because you haven't added any source code. Source code is basically another name for the code that you write. So we say new and what do we say? Class. We want to add a class. That's where we write code. Where do we write code? Where do we write code? Inside a class. All right. Cool. All right. So now give it a name. Let's call it Hello World just to be consistent with what we did. We did this and we did another thing. What was the other thing we did before saying finish?
Public static void.
We click that. Okay. So if you can't remember, this file is already there. It's always there for you to have a look. So where is it? Here we go. Step 2, select this. It tells you step by step exactly what needs to be done. Don't be afraid or ashamed to go back and do stuff if you miss things. So that's just expected. I expect students to revisit exercises and repeat them if they don't understand. Remember, this is about not leaving gaps. Finish. Okay. All right, then we said we want to add the print statement in there to print hello, right? So we said system dot out, and when it's done thinking, there you go, dot out dot print ln and open brackets quotation marks hello world. So I said that we need to tell the computer how to interpret stuff by putting or interpret data, right? So by putting quotation marks, we are saying, you know what, this is not a number. They are that dumb, all right? So you need to tell them, okay, this is not a number. If you don't put these these quotation marks, it's going to get upset, all right? So that's why it's put in that red thing there. So you need to put the quotation marks to say that this is just text. Don't worry about it. It's just display it the way it is, right? So we'll run it. So what goes inside quotation marks? Strings. And we get the output like that, right? We've done that already. So here's another version which is a little bit more fun, and I want to show more of that kind of stuff in the future. JavaX.swing. We'll look at what each of these things mean later on. And I want to say J option pane. Once it's done thinking, show. And the nice thing about Eclipse is the language reference is here. Okay, so you just hit enter and you can say null there. This is the exact same thing that's on your lecture slide. This is hello world here as well. All right, so hello world graphically. All right, so let's see what this one does. We run it and we get that message, and we get this one. We get a graphical thing. Now I like to get everyone to play around with the graphical side of Java because too many introductory programming Java subjects, they drill you with text. Even when you go on to do your second year stuff, you're still dealing with text. But graphical stuff's not that difficult. All right. So I mean, if you had not done any Java up until now, all right, you had to learn that you had to put this line to say hello world, right? Don't worry about these things just yet, but you know that if you put this and you type a message inside, it prints hello world or displays hello world down here. If you do this, don't worry about any other part, but if you write it like this and you put your message in here, you know that you can get a nice little dialog box. All right? Okay, any questions? All right, let's move on. Errors, and more errors. Now, if you get errors, don't be afraid of errors. All right, so that's another reason why people have so much trouble with programming. They get put off by errors. Before we go on talking about the right stuff to do or the right thing to do, let's take a look at dealing with errors, because that's just the reality of things. Now, if you did the tutorial exercise this week in the class that you were supposed to go to, I said debugging and finding errors can be as similar to finding the differences between two pictures, right? So you remember that. And I added some exercises. So so same story here. Open the Hello World program and let's find out how many different error messages you can get by breaking the code. All right, so you have this code here in your Eclipse, right? Let's try to take something out. Now let's go back to the original version. Don't worry about this one. Get rid of all of the extra stuff. All right, so this is the basic version that we have. All right, break something. All right, what can we take off? We can take the bracket off. All right, so what do we get? We have something saying there's a problem here. Just like in Microsoft Word or a word processor, you keep the mouse over that or you keep the mouse there. All right, what is it saying? Yeah, syntax error on token, hello world, and what is it saying? Bracket expected after this token. Now, maybe the whole thing might not make sense, but it said something about a bracket, and you look at it again and you notice, okay, there's a missing bracket. There has to be matching brackets, right? So this one is the one that corresponds to this closing bracket. So like that, what I want you to do now is get this code up and remove stuff like what I just did. Keep the mouse over the error over there or over here and write down what that thing is saying. And you can also say what you need to fix. So start with this one, syntax error on token. And ... you can say curly bracket expected after this token. And like that, try to break that program. You have Eclipse, do it in Eclipse. Try to find out what you can do. Break all the programs. Don't do too many things, just break one thing at a time. Right, so what did you find out? I'm sure you can do this on your own. I also took the liberty of trying this out a bit. Came across a nice list I created. Here's one. The method println, print in is undefined. So I put I there, right? So you get that error, right? So this is a little program, right? The smallest program that you can possibly write. And still you get a whole lot of errors. Syntax error, insert bracket to complete expression. There's a missing bracket there. Remember to submit your work. Yeah. And this is a missing semicolon. So you can try these things out on your own, okay? And string literal is not properly closed by a double quote. That's if you miss the quote there. See, they are sort of explaining what's wrong and what you need to fix. So what did I remove here? I removed the void, public class, right? So I removed the class and it's saying syntax error on public interface expected after this token. Now you might not know what interface means. Token sort of makes sense because it's like a thing. But by looking at something that's already there, you can tell that it's a word that's missing, and that's what this is actually referring to. So if you see that error again, you can you know how to fix it. So this one says syntax error on token hello world expected that. So like that, I came across a ton of stuff. Here I changed the mains capitalization. It's supposed to be lowercase. I changed it, and I got this error. So these are things that you can write. See, lots of things. So I came up with 13, 14, 15, 16, 17, 17 errors. And there's more that you can do to break it. 17 errors from our little hello world program that's supposed to work like that. All right, so try breaking it. All right, so we will be covering some of these topics in some order. Now, because the tutorials are there before the lectures, I can actually see how everyone is going and sequence things depending on where everyone's understanding is. I don't believe in a one-size-fits-all policy. So things will be made based on how people are following the material. So have a look at this link. It's pretty large. Just search, go to this one. It's what Java has to offer. It's a massive thing. If you go here and type Java 8 API, you'll get to the official documentation of Java. So these are all the classes that Java comes with. See that it's taking me ages to scroll through it, let alone read through it. So it's a lot of work, all right? And we can't, or no one can cover the entire thing in one go, all right? So, and there will also be a sample exam, and please submit your work now. If you you have about half an hour after this to finish and submit. And this is the end of the lecture. I'll see you all in the tutes next week.